Hello, Twitch. It's been a long time for me to see any of you, and some people's first times to ever be on the channel. Mo Alassane is joining us. He is an SA here at AWS. I am A.M. Grabelny, also an SA here at AWS. And we've got Ron, CTO of Epsagon, here to tell us all about Epsagon. But before we do that, Mo, we've got to introduce the show, this brand new show, right? We've never done this show.
We do. Yeah, we certainly do. AM, what is Howdy Partner?
Howdy Partner is the name of the show. That's it. That's all it is.
That's what it is.
Kidding. I'm joking. Howdy Partner is it's our chance to bring on all of our APN partner friends, the Amazon Partner Network. So Mo and I specifically work in the Amazon Partner Network, which is it's a pretty cool thing, actually. We get to partner up with companies that work alongside AWS and AWS technologies, and we get to be partners, right? We get to go to market together. We get to help people use AWS more efficiently. In the case of Ron and Epsagon, we actually get to extend out the features of AWS, right? So a lot of workloads running in AWS can benefit from the monitoring and observability of Epsagon. Mm-hmm. So we're going to talk about that more today.
And the most important one is to have live Twitch together.
Yeah, exactly. You can come on the show with us. You can talk to us about what it's like to be in the APN and show off your products. Mm-hmm. And like I said, most importantly, we're going to be doing this all this month, the rest of April, into May, all the way into June, right? I think we have some dates booked out in June too. So you'll get to come. I'll be on every episode just because I can't get enough of staring at my own face and hearing my own voice. And I just love the camera, and it loves me. So I'll be on every episode. But Mo, you'll get to join a few episodes, and we'll have some other friends from the partner team come join us as well. So I'm really excited to kick off Howdy Partner for the first time. How about you, Mo?
I am as well. So if you're watching and you're technical, if you're a developer or an architect, feel free to follow along and participate, learn maybe how to reduce some friction when building modern applications. And if you're non-technical, feel free to follow along, see how Epsagon can help you ship products faster, make dev time less frustrating for your engineering colleagues. So AM and myself, and maybe some others, are going to be posting links for you all, so you can maybe git clone the repos we provide and see all the cool demos that Epsagon has to offer.
Cool.
Sound good?
Yeah, that sounds great to me.
Awesome.
Right. Mo, you've prepped some content for us too. You're going to set the stage for us today, aren't you?
I did. So I wanted to set the stage and kind of talk about modern app dev, what it is, maybe define what a modern application is. And to do that, I'm just going to rely on this documentation here. I'm not going to be original at all. To define a modern application, I think this does it pretty well. It's an application that needs to scale quickly to millions of users, and it has to be able to handle.
Are you sharing your screen?
Can you not see it?
Yeah, you got to let me know. I got to switch us. I'm our fearless operator right now. Usually we have Cookie Points or AKA Paul operating for us, but it's me. So you got to let me know. Here, are you ready to share your screen?
I am.
Cool. Hey, there we go. All right, now we should be able to see what you're talking about.
Yeah.
So like I said, I'm stealing this definition because I'm not original at all. Modern application is an application that can scale quickly to millions of users, and it can deal with all of the data, the network traffic that these users are essentially inflicting on this application. And so to develop a modern application, you have to approach it differently than you would with maybe a traditional application. And so we'll start with these facets here. Architecturally, I'm going to lean on this demo just to kind of illustrate the differences. Architecturally, I mean, if you've been to an AWS summit or a conference, or maybe even looked at some YouTube videos of the reInvent talks, you've definitely heard of the monolith to microservices paradigm. And I think this demo does a pretty good job of illustrating that. And so a monolithic application as you probably know, is an application that's maybe easy to develop, but it's hard to scale. And it's hard to scale because as the code base grows, as you add more features, everything is tightly coupled, and so it starts to fall in on itself. Contrast that to microservices, where it's easier to scale because each service is a separate component, and so it's also theoretically easier to develop each component. But maybe there's additional complexity when you're looking at it from a high-level point of view.
There's trade-offs for both, right? Like there's trade-offs for going either direction. Sometimes it's easier to build a monolith right out of the box, especially if it's a smaller team, right? And you're not really needing to decouple everything. Maybe you're just trying to get to market, right? Like sometimes the fastest you get to market actually is the most important thing. So if you got like a team of two, it's just me and you, Mo, building a startup, which one day we can dream.
So let me add to that though. We would probably do it serverless, right? So we probably might not do it monolithically to begin with. But yeah, I agree. I agree that sometimes maybe you just want to go the monolith route because it's just easier to develop, especially on a smaller team. So
you and I are serverless friends, right? So we'd probably build a lot serverless first.
So to illustrate what maybe a monolith looks like, I've taken this demo, and AM, you can maybe throw this link in the chat. But I've taken this demo.
Actually, if you hold on one second, if you do this command right here, GitHub, this will take you to the GitHub repo Mo's working off of, and if you do docs, it'll show you exactly the getting started guide that Mo is working off of.
We have a Twitch Pro. All right. So to illustrate this, I've spun this demo up in two regions. This is North Virginia. This is the monolithic application. And you can see there's just one service. It's this API service. And I'll show you here in the code base. And then this is the microservices application. 3 separate services. We just kind of took a peek. It was posts, threads, and users. So right here. And I guess I wish I could illustrate what scaling looks like, but I'll just show you kind of. So this is the user's endpoint for the monolithic application. Again, we're in US East 1. And if I were to somehow generate enough load to make this need to scale, then what would happen is all of this would scale together. Even though I'm just querying the user's endpoint, the threads and the post would scale as well. Contrast that to US East 2, which is the microservices. And here I could also query the user's endpoint. But if I generated enough load that the user service needs to scale, then it'd just be the user service that's scaling. And switch over to the code here and show you what that looks like. So again, this is the monolithic application. This is the service. It's just one service. It's the API service versus the microservices, where there are 3 distinct services and they all have their own assets. And that leads us to the next thing, which is data. So I think this does the best job of illustrating. These are databases. This DB.json file is the database. And in the monolithic application, you can see that all the data is in one place. All the posts, all the threads, all the users' data is in one place. Contrast that to the microservices application, where the post service has its own quote-unquote database. The thread service, same thing, and the users, same thing. And what that kind of illustrates is that when it comes to microservices in modern applications, data can be quote-unquote decoupled and purpose-built. And what that means is you can have a one-to-one mapping between the database and the specific service, but you can also choose the right database for this service that you have. So if we go back to this users, for example, if I wanted relational database as opposed to this, I could make that change to the users without theoretically impacting the threads or the post services.
Yeah, I wanted to call out one thing. Oh, sorry, Ron, you go first.
Yeah, I also wanted to chime in and say 2 more things that really stands out as we move completely to microservices approach. First thing is that it's okay to have the data replicated in many places. I mean, it's okay if you're storing some information of the user in users and some of the information of users in threads. That's okay to have it replicated, because honestly, storing the data is cheap almost anywhere today on AWS. And the second one is, it's okay even to have more than one data store for a single service. For some of our services, we have 3 different data stores, one for, fast access, the other one is for more aggregated SQL queries, and the other one is more about big data analysis. Like, we employ, maybe RDS, Athena, and DynamoDB at the same service for different purposes. And that's okay, because each data storage has its own purpose, and you just need to make sure you're using and leveraging the right one.
Yeah, I was going to say, like building it this way, building with microservices, having like data stored separately according to a service, right? It also lets you, I love this term. It's such a buzzword. Purpose-built database, right? Like, you can utilize a purpose-built database for the use case that you're actually trying to solve with whatever service you're building. So you're not locked into, building against a SQL database just because that's what database you use for users, and that's the only service you have. Like, not everything's coupled together, nothing's decoupled. You just have to use one database. Now, that being said, it also brings into the fact that you're using multiple databases now and need to have people on staff that understand all those databases too, right?
Right.
That's more complexity that you're adding to your architecture as well.
So let's talk about those people, right?
Yeah.
I think that's when software delivery comes in, and I think the underlying themes here, to rip them off the page, are automation and standardization. And to me, what that means is maybe you have teams organized around a single service. You hear a lot of talk about 2 pizza teams. So maybe the size of the team is limited by whether or not they're able to be fed by 2 pizzas. It's something that you'll hear a lot in the presentations that AWS people give. But maybe those teams are obviously encouraged to release updates independently. They're using automated release pipelines like CI/CD, and they're probably leveraging infrastructure as code as well.
Now, Mo, I have a really, really important question. Okay, it's very important.
Yeah.
About 2 pizza teams. If I can eat 2 pizzas, do I become a team? Do I inherit the powers of a team if I can eat 2 pizzas myself?
Ron, what do you think?
You're a team. Am is a team. Am is a complete team. He can do everything from end to end. He's a DevOps, he's an SA, he's the team leader, he's doing the evangelism, he's everything. He is the team.
Oh, yeah.
Wow. Just go on. This is the whole stream, right? It's just Ron complimenting me. This is great.
Let's talk about operations. I think one of the other elements.
Talk about something else.
About operations. Stop flattering you. But I wanted to pick on Ron. So if you go to Ron's Twitter page, which you should be following Ron for sure. This pinned tweet here is this picture of a reInvent slide deck that says serverless is an operational construct. And when it comes to modern app dev, you're kind of encouraged to pick how much operations you want to manage for each service. So if you're focused on becoming more serverless, if you want to focus more on the business logic of your application, then maybe in the compute layer, you choose between Lambda or Fargate. In the databases layer, you're choosing between DynamoDB and Aurora Serverless. And in the integrations layer, you choose between SNS, SQS, Eventbridge, which we'll also be talking about today. But those are all things to keep in mind when you're looking at the operational construct, I guess, of a modern application and how you approach developing it. And then lastly, to kind of wrap up, I wanted to talk about security and how security is different in modern applications. Obviously, security becomes not just infosec's responsibility. You'll find elements of security in the whole development lifecycle of an application. And so maybe you're doing vulnerability scanning in code repos. Maybe there's security in the build management and deployment tools. And yeah, there's this buzzword, DevSec Ops.
My favorite.
Do you want to clear that up for us?
Yeah. and this is not a slight to anyone ever in the world. I don't like to exclude anyone personally, but there's a part of me that believes that DevOps is an excuse that some businesses use to be able to pay one person for actually doing two jobs. I think there's some principles in DevOps actually that really do apply and that are important and that will make a huge difference in the way that you run your engineering team. But you can also be taken advantage of, in my opinion. They've also added to this is like a new movement that I've heard about recently called Devsec Ops, right? And so at the heart of this, in my opinion, how this should be used is really not pushing the responsibility of having a security team or an ops team onto the software development team. It's actually just reframing how software developers think about building software. There's not a team that there still should be a team in my opinion, but you're not going to push the responsibility of security off to another team. You're going to build it into your software as you build the software. And then you're going to have, a security team there to be enforcing best practices as well. That's how I think it should run. What do you think, Ron?
Same thing over here. I put the perspective on the monitoring aspect. So, we used to have like this kind of IT and operations department that used to monitor all of the infrastructure. And today it's completely changed. Before a team launches a new service, he is the one that gets the ownership to make sure, that the RDS is working properly and the service gets the right scale and everything works according to the SLA or the metrics that he's providing. So it really, it being taken as part of the development and engineering team to be responsible from end to their services and their applications, rather than, putting to different teams every different aspect.
Right. I think all of this is to say, not just the security, but the architecture, the software delivery, all of these elements of modern app dev are supposed to come in to provide these theoretical benefits. You're supposed to be able to go to market faster. You're supposed to be able to increase innovation. You're supposed to be able to improve reliability, reduce costs. But kind of touching on what Ron said there, I think there's an element of distributed observability, buzzword, that you need to be able to answer like three essential questions, which are, how do I solve my problems faster? How do I do performance tuning? And how do I do cost optimization? And if you can't really answer those three questions without having the requisite distributed observability capabilities that you need. And so I guess that's the perfect segue into Ron teaching us about Epsagon. But before I do that, if you're just joining us, we're talking about modern app dev and observability with Ron, the CTO of Epsagon. So Ron, take it away.
Amazing. Thank you very much, Mo. So it's a pleasure to be on the first episode of Howdy Partner. I would love to share my screen now. So if you can put me live, that would be perfect.
Let me know when you're ready.
Awesome.
You ready?
I'm ready. Yeah.
All right.
So the thing that I'm going to speak about mainly around this discussion is observability. And I'm the kind of person that really hates buzzwords, but I'm really going to describe what observability is and how do you implement it on the day-to-day and what are the best practices. And, it really follows most conversation about modern applications because it completely changed. And I want to start with, talking what's the change that has been made and how do we treat applications in production today. So just a few words about myself.
Real quick,
go ahead,
sorry. It's AM. I was just going to say, I think Mo's setup for you is really perfect here, just because when we start making distributed microservice, modern applications that we call it, observability and monitoring is very difficult at this point, right? Like that's one of the added difficulties that you get when you split out all your services, because it's not as easy as just dropping like a Java logging library into your code now, right? Yeah. It's a lot more complex on how these services interoperate, and you really need tools built for solving this distributed architecture problem. Mo, you're going to say something.
Yeah, I was going to say that it's certainly complicated doing it by yourself as a team of one or maybe two. It's like levels of magnitude more complicated when you have teams who are trying to ship software together. And so, yeah, Ron, tell us about yourself, about Epsagon, and how it can help with all those issues.
Awesome. Just before I'm telling about myself, I would love to hear about you too. So if you can share the links, they're going to be 3 QR codes or links in the Twitch to get to know you better and understand the kind of our audience. So that would be perfect. And about myself, I'm the CDO at Epsagon and one of the co-founders. I'm an AWS serverless hero, which means that I can speak anything of any topic that I want about serverless and people would believe me. In the picture over here, you're seeing me looking for whales in Hawaii, but I couldn't find any. And as they mentioned, Am and Mo, my Twitter handle is RunRib. I'm talking a lot about infrastructure, serverless cloud, and these kind of topics. And just because we're doing a Howdy partner, I really hope that this would fit the theme. I hope that everybody sees the animation. So let's get started.
Idiot.
Yeah. Wait, do we have to tell people what Howdy means? Does everybody in the chat know what Howdy means? Can somebody in chat define Howdy for me? You know, it's one of those words that probably has a different meaning to everyone.
It's like hey for cowboys or Texas people, or I don't know. That's at least the Texas greeting. That's the thing.
So Mo and I are Texans. Mo and I we both live in Austin, Texas. So we had to put some Texan flair on our show.
Yeehaw. Yeah. Idiot.
Awesome.
Oh.
Ron is left.
So
Sorry.
You to go on. I'll just drop off. No, just kidding. So today we're going to speak about monitoring and logging, the old kind of monitoring and logging, and then we're going to speak about observability. And actually, to fit this kind of missing topic would be the distributed tracing to really understand complex systems. So let's get started. I think that we had enough of background and intro. Why are we monitoring? It's pretty simple. Some people tell me because we need to make sure the metrics look okay or that the application is running, but the ultimate goal is to make sure that our business works. In most of our cases, most of the audience probably that hears that, the application is our business. So when the application is working, it means that our business is working. That's great. What do we monitor? Like, how do we start this kind of approach? I think that Google did a really awesome job with the SRE book. Actually, I forgot to mention the link, but if you just look for Google SRE, you would find it at the first result. It states 4 golden signals, like the 4 vital signals that you should measure when you're having an application at any kind of, like whether it's distributed or regular, or monolithic, or any kind of environment. First thing is latency, understanding how long it takes for a request to come in and get back to the user. This is super important because if it's too slow, it means that your users or customers wouldn't experience something good on the product that you're delivering. Second is the amount of traffic that will tell you, hey, how much users do I get per second, per day, or just what's the traffic looks like to be able to monitor it. Then obviously comes the errors, because if we're having errors, obviously it's a direct impact to our customers. And then saturation, which I think many people miss this kind of metric, because when you're monitoring traffic and errors and latency, you can have so many changes, but nothing will tell you how fullness is your service. I'm sorry if it doesn't translate well in English, but like to understand how much capacity left in your service to operate, because you don't know when you'll get a strike of many people and your service will get denial of service or something similar. So these are the 4 golden signals that Google recommends, and I'm really sticking to follow these kind of signals. And in the old school kind of days, the way that we used to monitor, if we had this kind of application that composed with a REST API that gets the request and a database adapter, you would have an agent sitting on that infrastructure or that host or that VM. It would collect the host data. It means like processes, memory, CPU, disk network, and so on. And it has a main limitation, inherent limitation. It collects only metrics. It means that it has no data. It will just collect data points about, at this timestamp, we had this amount of CPU usage and, any kind of metric. It doesn't collect any payload or any information. If I'm seeing a spike in CPU, it wouldn't tell me anything about what caused it or what happens. That's why we need troubleshooting tool. And this kind of debug data is exactly the logs that we're using to ship somewhere. And the way we did it is by having another agent, usually, that can dump the logs from locally to remotely. You know, in the old kind of system, it was locally, so we were SSHing into the server or telnetting if it's even older. Or today, more modern kind of approaches is to ship it remotely to some aggregated solution that will show me all of the logs. Here, the only main problem is that it transfer only log data. I mean, if in my code I haven't printed out something to the log, it's not going to appear in the log. There's not a magic logging solution that just generates logs for me and ship them somewhere. So with that being said, let's shift into the future of applications. Applications are using cloud, microservices approach, serverless infrastructure, more and more managed resources. Any kind of trend shows this kind of increase. And as you see another QR code, some other link to learn about your kind of applications to see what kind of engagement are we seeing in our kind of crowd. And Mo described it perfectly. We're moving from a host-based, running on a monolithic kind of scenario to a more abstracted host, which means that I'm using managed cloud services like managed queues, managed databases, managed storages, web servers, and so on, or even third-party APIs like Twilio, Stripe, PagerDuty, and so on. And all of a sudden, instead of having a single place where all of my application is running, it's starting to get more and more distributed, more and more event-driven. This is really complex to understand. And talking about the actual challenges for engineering and DevOps, so when your application is getting more complex, troubleshooting time becomes much slower. It takes much longer to understand the root cause and connect the dots, just as we see on the right-hand side. And this is a simple example. I mean, some applications today are having hundreds of services and different teams. It's really becoming very complex today. Second is monitoring, just to understand, this kind of metrics that we spoke about. What's talking to which service? Do I have any bottlenecks? What's the whole architecture looks like? Are things that are getting harder and harder to answer, especially on a real-time, on a dynamic environment in production. And both of these things really impacts my development process. As a developer, I'm experiencing most of the problem in dev stage, like when I'm deploying locally or to my dev environment, and I'm testing out my features. And if I'm having a right tool that tells me what happens in production, it helps me solve problems in production fast, it's also going to impact my development. And it means that I can focus more on developing features and shipping feature faster rather than, moving slow with my iterations.
Yeah, I want to pause you there real quick, Ron. For anybody who's joining, we're on stream now. This is the AWS channel. Welcome if you've never been here before. We're talking with Ron from Epsagon. Epsagon is a member of the Amazon Partner Network, and it's a monitoring and observability tool that you can utilize alongside all different kinds of workloads running in AWS. You mentioned previously on a slide there, Ron, some serverless workloads and some container-based workloads, right? And that seems to me to be like one of these big, which one do I use? This one's better than the other one. I should only build stuff this way. And I think like this slide, all the way onto the right-hand side of that, it's really important. I think with both of these types of building, and I want to hear your thoughts on this, Ron, but with both, right? With both of these types of building, we're really just building with abstraction, right? At the end of the day. And I think that applies to other services too. You have things like Stripe for payments, right? That's just an abstraction away from me having to build that myself. Same with serverless, right? It's just an abstraction away from me managing infrastructure. And with containers and Kubernetes, it's just an abstraction on how I interact with underlying infrastructure and how I package my applications. But what remains true for all ways that you deploy, right, is I still have to know what's happening inside all these services and what's failing. And like you mentioned, your saturation, right? Which service is being hit the most? So I just wanted to call that out for anybody joining the stream right now. We're going to be getting into a hands-on demo here of Epsagon soon, but sorry, Ron. Keep on going.
No worries. And by the way, I haven't mentioned I'm from Tel Aviv. I got the Israeli chutzpah, so I just wanted to ask questions while I'm speaking. If in any case I'm missing it, just, Mo or Am, just, ping me, because I would have a hard time to focus on both things.
Totally.
With that, coming back to what we talked about. So, we talked about what's monitoring, what's logging, but I think that we need a bigger definition, something that covers a better term for looking at this kind of applications. And again, last QR code, last link for the survey. I think that being able to have metrics, logging, and traces all under the same tool really helps teams move faster, because today you're having one solution that you put all these metrics to that will tell you, you had a spike in, in the CPU of your RDS, and then to troubleshoot it, you're going to a different solution and try to, sift your way through tons of logs and understand what correlates to this problem in your RDS database and understand which query was affected and so on. And they're not correlated to one another, and you can't really scope out what's the old process that led to this kind of problem to the database. So being able to have all three together under the same dashboard really helps teams today. And that's observability, and we're going to drill into each and every topic. So let's start first with logging best practices. First and foremost, I can't say it enough, print out structured logs, JSON, dictionaries, whichever your preferred language is it, and enrich it with metadata. I mean, instead of just printing a log line that is super textual, that can't be indexed, that searching would be a nightmare, print it in a structured way, and I'm going to show an example very soon. Secondly, try to automate as much as possible the logging process. As I mentioned, logging has some inherent problem that if you're not logging it in your code, it's just not there. So as much logging that you would make in an automated way would just reduce you all the friction and the annoying part of missing things when you're troubleshooting. And last but not least, probably you're using like Elastic or Splunk or some aggregated tool for logging. Index the field that you're using. It will help you to get some more aggregative information or to pinpoint events that are tailored for your use case. With that comes the first demo time, and as the girl says here, I hope that I won't burn everything alive. So I got the first example over here. I hope that it's not too small. I'm gonna enlarge it a bit. Sorry, I haven't mentioned, in this case, all of my demos are going to be Python and Flask. Super simple to understand, no complex setup. Install Python, pip install Flask, and you're ready to run my examples. And if you want, by the way, I can share them as a gist on GitHub if people will ask for it. So starting first with structured logging. If you're familiar or not familiar with Flask, I got an example application. Here I'm importing the Flask. And down below, I'm going to create an endpoint that is going to get requests as a get method on the main endpoint. Pretty simple. It's going to log some information about which user got to what endpoint, and it's going to return an hello world. Pretty simple. Let's
real quick,
hit it
Ron.
off.
Sorry,
Yeah.
not to be that person, but what is Flask? Can you, for anybody who's not a Python dev, can you tell us about Flask?
Yeah, in short, Flask is similar to Express or to Spring Web or to, any other kind of web framework. In long, it's a web framework built in Python. It's the kind of slimmer version of web framework. There is Django that might be more popular, but it's more fully featured, means that it's a bit more like slower. Flask tend to be easier for smaller projects. And that's my preference for every kind of project. Almost any project needs a web framework that would get requests either in REST or HTML or any kind of protocol.
Yeah, Flask is primarily for building like HTTP APIs in Python, right? Do you think, is that a fair assessment?
Exactly. So I'm going to run my first Python structure logging Flask application. It already listens on port 5000. And I'm going to send the first request. The details are going to be pretty straightforward. I'm going to get to the main endpoint, and my user would be test. I'm going to hit the enter. I'm seeing that I got the hello world response. And if I'll go back to the Flask, I see that this is the built-in logging from Flask. And this is the logging that I've made. Got user test in endpoint / So far, so good. If I would need to look for that, like if on logging dimension, I need to look for a user test hitting an endpoint, I would have to search all of this information. It's not very easy. And if I'm having the same log line across multiple Flask applications, multiple services, multiple, it can be a nightmare to look for such an event. Instead of it, I want to show you another way to take this existing log into something more structured. And again, without changing the logs in your service. So I'm going to create a formatter to my log. The formatter is going to be structured log. This structured log is mentioned over here, and I'm going to uncomment it. All it does, basically, when we're formatting a record, it takes the original message and puts it under a message, and it adds some more metadata around it. For example, which file name printed this kind of log, what was the log level, what was the time that it was printed on, and some more information about the service and the stage, because I want to look for that user specifically on production or development stage, this kind of information I'm getting from the environment variable. And that would take any kind of message that, I'm logging and would use that. Again, very structured, very simple. I'm going to hit the save button. And I'm seeing that my Flask application, since it's on a debug mode, it's already reloaded. And I'm going to hit another request with the user test. This time I can see that my message was printed out with some more meaningful information. So I got the same message. And by the way, I can make it even more complex, but to that scenario, it's still a bit simple with the level, which is warning, with the file name that printed out, time, service, and stage. Now I can filter for the same element, but with more detailed information, like the time that it was printed out, the service that it took part of, the stage that we're working at. So that's how we can take an existing log and turn it into something a bit more meaningful. In terms of the monitoring best practices, so I think, again, this is pretty straightforward best practices, and I urge all of you to see if you're meeting this kind of this standards. First is to aggregate all of your metrics into a unified dashboards, because if you would have several dashboards for metrics, one for your VMs and one for your on-prem and one for your cloud and one for your managed resources, it's going to be a nightmare. You're going to end up figuring out which metrics goes to which service and what's exactly going where. So having everything under the same dashboard makes it much easier for everyone. Also, define your critical metrics. Like when we spoke about, for example, the 4 golden signals, you don't want to get alerted for every error that happens in your service, because probably you're having, everyone's applications is perfect in production, no errors, but to be honest, errors happens, and you not want to get awake in 4 a.m., like in the middle of the night, for a random error that it's not really critical, nothing really happened. This creates this kind of alert fatigue. You wake up in the morning and tons of alerts popped out, and you're not really sure what should you handle first. So setting up the threshold, it's super important, because you want to get to a Zen mode that every alert that you're getting is super important. It's something that you need to troubleshoot now, because it's super important. And it's okay maybe to define even 2 thresholds, like one for warning and one for like an actual alert. So a warning, you're not going to wake up, but you want to understand what happened. And an error, it's something that you wake up.
See, this is why I'm actually against DevOps, Ron, is because I just want to write the code and I don't want to be woken up at 4. So that's the ops job, right? Is being woken up at 4. That's the ops side. I just get to write the code that breaks, and then somebody else has to worry about it breaking, right? I'm kidding.
Exactly.
I'm joking.
Last one is to use custom business metrics. as we mentioned, the application is our business. So if we can put some metrics like, if I'm having a checkout service, so how many items were in the checkout, or how many minutes watched if I'm the kind of, streaming service, all these metrics will help us to, understand better what's actually going on inside our services in terms of usage. And when speaking about monitoring, some people think that just looking at CPU or memory or network or things like that, that's enough. But you need to make sure that you're monitoring also your application level metrics. For example, what's the average duration of a call when you're making your calls to Stripe or Twilio or other service? What's the minimum number of calls in a message queues? Because let's say, for example, everything looks right, but you're not getting new incoming traffic, that's a bad signal. And you want to get alerted when you're having less traffic than you're expecting. And also, just number of 400 or 500 errors that will tell you how many errors is there on my Flask application, for example. Now comes the second demo. Before we're jumping into the demo, obviously the girl got tweaked.
Yeah.
So,
Mo, wait, Mo, do you have a hat? Do you have a cowboy hat?
I don't have a hat. I don't have a hat. Should we get some? Like 10-gallon hats?
I don't know. Can mine say Vans?
I don't know. Maybe. Hey, if you know anyone who works at Vans and you're watching, you want to make AM a 10-gallon Vans hat, that would be pretty cool.
I'd wear it every stream. Absolutely, 100%.
yeah. So in this example, I'm going to show the APM middleware. So more automated approach that brings me also, information about my application, my Flask application. So I'm having the same endpoint, pretty straightforward. And I'm going to create something that's called Flask Middleware that wraps my Flask application. This Flask middleware is super simple, as you can see in all of the code over here. It listens before and after the request. Before the request is just starting the time measurement, because I want to understand how long requests are taken handling. And I'm just going to log the information about duration, the path that I got, the status code, the content left, and the app name. All this information, just as we used before, the logger is going to use the same formatter that will print this information as part of the other information that we already know about, like the level, the file name, recent stage. This is, again, a pretty straightforward kind of example. Let's see it to see actually what we're going to observe. So I'm going to run the APM middleware, and I'm going to set, again, another request. This time we're seeing some of the previous information, but now I got a duration, I got a path, I got a status code. Now think of it, how easy it would be now in my logging service or metric service to say, hey, I'm interested to know how many requests that were 500 did I get in the last day on that specific endpoint. Or just to understand, over time, what's the response duration, like what's the latency when a user checks out items in my shop, because I want to make sure he's having the best experience. And look how, without any code changes inside my Flask application, the Flask application remained exactly the same. I'm capturing some more information that is vital. It's vital for us to know what's going on.
I think that's really important, right, Ron? Like that's actually a really, really difficult thing to do with no code changes, right? Like to come in, make sure you've got this added monitoring in place, but not to have to alter the underlying project, right? That's huge.
Exactly.
Cool.
With everything that I've mentioned, something is still missing. At least for me, I guess that for you, something started to pop out, because everything that I've mentioned isn't really related to the complex of the system. Like it would apply in old generation applications, new generation, any kind of application. But now what happens when I'm having a problem in my one of my endpoints and I need to understand exactly the breakdown of the call chains? Like, we
got a quick question, Ron. Sorry to interrupt you. I think it's from the fraud, which I think is a personal screen name made just for me, right? Because that's what I am and feel like most of the time. So the fraud asks, what should be this person's KPI of measuring success of actually implementing tracing? Like, once I implement the tracing, how do I actually then measure that I'm using tracing successfully, right? I think is what the question is.
Yeah, actually, I'm going to speak about it right afterwards, but just as a teaser, I think one of the main measurements for having a good tracing is the efforts that your engineers or whoever takes care for it is putting into place. A not good tracing or monitoring solution would mean that you're constantly adding more and more code. Your code looks ugly. You need to maintain it over time. And nobody really remembers what someone else did 2 years ago. And on the other end, if you're having the right kind of tracing, it's almost seamless. No engineers is even aware of what is trace or how do you do even more complex things, because this was super simple. And moving forward, when it's getting complex more and more, every engineer is just almost seamless or transparent to him what's exactly going on, because everything is already automated.
I've never heard it actually put that way. That's I've never thought through that, but like the minimal effort that it takes to add tracing is actually a metric used for the success of adding tracing. That's really interesting. I haven't thought about it that way. That's really cool. We have another question, and this one's around. It's a DJK SK 8LIF asks, what about test-driven development? Any opinions on TDD or even just writing test cases? This person asks around developing a small application. What do you think about that,
Ron? I'm in favor of doing TDD. I don't really think it impacts the topic that we're speaking, because even if your application is fully tested, like you're the best kind of coverage and unit and staging test and so on, still in production things go bad, and you need this kind of observability, as we spoke about in your production. So I think these are two a bit of like orthogonal topics. Doing TDD is great. It might reduce the amount of time you're spending on troubleshooting production bugs, but all of us know that you're going to have production bugs even if you're the best at testing.
Yeah, I agree. What do you think, Mo? What do you think about testing?
When I'm like building my own stuff, I don't really, usually it's like internal or just for fun and I'm trying to learn. I don't really bother with writing tests. I just kind of try to break it as much as I can while I'm developing, I guess.
Yeah, I think this could become a philosophy and less of a tool. You know what I mean? If you let it, right? It becomes philosophical in the sense that you're writing tests just because you set out the goal that you were going to write tests. It actually doesn't impact, or maybe you're not writing enough tests on the other side, the flip side of that. So I think striking like a balance and taking into consideration what you're making, right? Like you're saying, Mo, you're making something that isn't production grade or is just for learning. Do you still take that TDD approach just because you philosophically agree with TDD? I think that's a philosophy and not an actual practical use of the utility. So
my personal favorite, by the way, is to test live, like ship my application into production and let the user inform me of any bugs or any issues. That's the best.
Yeah, that's definitely the cheapest testing, right? Unless people get too upset with your product and stop using it. But no, totally. Mo, do you want to give us a recap of what we've been doing, and for anyone joining the stream, tell them what we're talking about today?
Right. Yeah. So if you're new to the stream, we're talking about modern app dev, and specifically we're focusing on observability. With us is Ron, the CTO of Epsagon. And he's teaching us all the best practices, and he's about to show us another demo.
He's lying. All we're doing is just looking at funny memes, talking about Texas. We haven't done anything that he mentioned.
We're trying to get hats from Vans, like 10-gallon tall hats that say Vans, and Mo and I will wear them on stream. So just, if we can get free stuff.
Awesome. So I'm just gonna recap quickly. We talked about monitoring, we talked about logging, but something is still missing that is special for distributed applications, ones that are managed. First thing is correlating between the problem that the metrics tells me. For example, as we mentioned, CPU in my RDS is spiking high, and what exactly service is being impacted, and what's the actual impact, and which users are being affected by that. Doing this kind of correlations, two different tools, two different kind of sets of data that I need to explore. That's a lot of manual work to do. The second one is actually when I'm starting to drill down. So and when I'm looking at the metric of the RDS spiking high, I want to correlate the old flow that led to this spike. Like, is it a single service, or is it impacting several services that are communicating to the database? If I'm looking at the logs, I want to see the whole chain of events since the user started his request all the way to the database, because I want to make sure that I'm following a request as it propagates through different services. That's exactly where distributed tracing comes to help. And distributed tracing, honestly, what it tells is a story. We can call it, instead of distributed tracing, storytelling. Storytelling about how a request is moving from one service to another, from my client to the load balancer, to the authentication service, billing service, another resource. And I want to understand the journey of everything that led from one point to another. So that's distributed tracing. And in order to do distributed tracing, we need two things. We need to generate traces, and we need something that will get these traces, and a client that will visualize or do something with these traces, because if we're just collecting information but not doing anything with it, it's meaningful. For generating traces, we got open tracing and open telemetry that are part of the CNCF. And for ingestion and client, we got Jaeger, that is indeed part of the CNCF, and Zipkin or Open Zipkin, that is not part, but is also a great open source tools. All of these are obviously open source tools for distributed tracing. Let's start first with generating traces. The first thing that we need to do is to instrument our calls. Instrumentation, and this is really touches up the point of how do I measure a good kind of tracing? I want to automate it as much as possible. Instrumentation helps me to automate it. I want to make sure, just as I did with the Flask, that every endpoint that will get called, I'm already capturing the information. Same will apply for my Express, Spring, call to my Postgres, my HTTP clients, AWS SDK resources. Everything should be captured in an automated way. Otherwise, it just means that every developer would have to annotate like a few lines of code for every call of these services in my system. That would end up in tons of code, constant maintenance. Any change would probably break up everything. So instrumentation is the first part. The second part, and this is starting to speak about the tracing jargon, like the terms. First, I need to create a span for every request. Span in open tracing means that I've got an operation that started at some point and ended at some point, and it happened on some resource. So that's a span. So I need to do it for every time I'm getting a request and response from this specific service or call. Next, I need to add some context. For example, if I'm calling to some HTTP, for example, to Stripe, I need some context about what exact endpoint am I hitting, what was the status code in the response, which user, for example, am I charging. All this context will help me understand afterwards, when I'm looking at the trace, what's actually going on. And ultimately, I need to inject and extract IDs. This is the core thing of doing distributed tracing. When I'm moving between services, I need to let everyone know. Let's say I'm calling an HTTP endpoint that apparently is service A calling service B through an HTTP call. I need to inject in this HTTP call some identifier that will tell, hey guys, anyone that is listening out there, know that you're part of trace X. If you're going to continue trace X. And on the other side, the receiver part would need to look at the incoming request, look for that magic, and say, do I got anything familiar? Do I got any magic that tells me that I'm part of something? This is the extract part. And if so, I'm going to continue using that same distributed trace. Otherwise, I'm just going to create a new one. This inject and extract idea is, it can span over HTTP calls, message queues, AWS integrations like, S3 trigger or DynamoDB stream or Kinesis or, any kind of service out there. It's going to be a lot of manual work. And again, this is really talking about instrumentation. I want to make sure the inject and extract are being done at every call automatically. Just to give a really short example out of it, this is taken from Open Tracing. I know that it's not super readable because it's a lot of code. So let's jump to the demo time. This time the girl already got her hat, and now she's going to say, "Howdy, guys."
She looks like Andrew Lincoln from The Walking Dead with that hat. Rick.
Yeah.
Rick.
So this time I'm going to add tracing to my Flask application. Again, same route, doing the same Flask middleware, but this time I'm going to use the Open Tracing library. So the Open Tracing library, we got it from here. Pip install Open Tracing, again, super simple, nothing special to set up. And in this example, we're going to handle the before and after request to create a span and add some information. So when I'm getting a request on my Flask application, first I need to say, hey, somebody extract the headers from the HTTP. This is an example of an HTTP headers, because I need to understand if I'm part of some other span or part of some other trace, and this is to the span context. Then I need to create a new span that will tell me, okay, now I'm handling a new request, start a span for it. I'm going to add some more tags to it, so I will be able to filter that, index it, aggregate it to some extension. This is the context that I'm adding to my span. So for example, what URL was being hit, which user was part of this trace. And after I'm finishing the request, I'm going to add some more information about the response. For example, what status code am I returning and the duration. So this is, again, pretty straightforward to capture some information in an automated way. I'm going to run it very quickly. There's nothing really special to see about it because, sorry, we're collecting a trace and that will work. But let's just see that it's working. So I'm running the same Flask application, but now the tracing part, I'm going to hit the request. And I see that I capture the span, which is Open Tracing span object, ready to be shipped out somewhere to be consumed. So this is, again, this is pretty similar to what we've shown before, but this time, like, I really think that it boils down, the tracing is a structured log, except for the part that it helps us to correlate between different services. But I'm doing the same, like what's URL, what's status code, what's duration, all under a structured kind of payload that's called a span instead of a log. And now with using different tools, I can gain some more information or do some more sophisticated stuff on top of it.
So that was the demo. Once we're already having this
ship it somewhere and start ingesting this information and having some plan that visualize it. The first part is to handle the ingestion. Are we talking about millions or billions of requests? How are we going to index all the context and tags for easy search, for example, for a specific user? How are we going to visualize traces? Will it be timeline or a graph? Do we get alerts when something bad happens, if there is an exception or a 500 error? And some more and more things that we would love to see in such tracing capabilities. Just as an example, Jaeger brings out of the box the timeline view, but roughly that's it. Like, we can see a request propagates through our front end, to our back end, Redis calls, and everything else that happens. We can see exactly how long each operation takes along the time. So, if I would tell you, for example, generate this from logs, it would be a nightmare. You would need to look at every log and generate it manually. It's not doable, especially when it's getting more and more complex. So that's the tracing. Now, I think just before running into, actually I have another demo. You know what? Let's see what's happening when, a surprising demo. Let's see what happens when we're doing the kind ride of tracing, or when we're having a tracer that takes care both for the tracing, like the generating the traces, and the visualization. So I'm going to have an EPS example that is going to be super empty. Actually, all we're doing here is just to use Flask and within our endpoint to call some random endpoint, something that will, create some more meaningful information. But actually, we haven't done anything. You can agree with me that this is the most basic code. I haven't done anything to trace or to log or to do anything in my Flask application. So let's see how we can leverage something more meaningful. I'm going to stop the previous one. In order to get started with Epsagon, I'm going to zoom this out. I'm going to use a token. I'm going to set an application name, all set by environment variables. I don't need to change my code. I'm going to set some more specific information that I need for this demo because I'm running from my Mac and the internet in the world becomes slow. And I'm just going to run my Python EPS example with another environment variable. So let's take it for a spin. I'm going to set all the environment variables, and I'm going to run my Flask application again. And I'm going to hit the request over here. And I see that the request was handled. I'm going to hit some more requests just so we'll have some more information. And now I'm interested to see what it'd be to have a good trace, to have everything running, to filter that data, to see exactly what's going on. So I'm jumping into the Epsagon dashboard. We're going to do a more live demo afterwards, but just to visualize this part, this is the traces search screen. In here, I can search for any trace and understand exactly what happened. When I'm hitting the search, I'm already seeing some of the information that I already got. For example, 6 success events, and what's the average duration that they're taking. And as I'm scrolling down, I can see exactly all of my Flask calls. Now, with logging, it's really hard because you're the one that need to correlate between the logs. But let's say I'm interested in exploring this specific request. I'm just going to click on the event, and all of a sudden I'm revealed with a full story, like what led me from one point to another. So this request started with an HTTP call that took 327 milliseconds to my client. I can see exactly what was the base URL, the path, the status code, the user agent, what was in the headers or the request information or the response headers. Everything is visible for me for exploration. This is a good kind of tracing. Now I can drill down into my Flask application to see what endpoint was being called, what was the query string, so I can see exactly the user that I'm hitting, and any other information that can be helpful for me, and any call that was being made. And as you saw, like literally there is no any additional code in my Flask application. Somebody took care to generate the traces, index them, parse them, analyze them, generate aggregations. This is really helping, the KPI of I'm an engineer, I need to focus on what I'm building and not building observability tools and doing tracing. So that was the last example. If you have any questions from the crowd, how it works, what it does, feel free to ask. I'm going to drill down to more of it very soon, but that was the example.
Yeah, I think something that's really cool here that we haven't really highlighted yet is that, not only does this information really help you monitor your system, right, and know what's going on, and maybe you make decisions based off that, but now you actually have that data as well, right? So maybe you have a piece of your service, that JSON placeholder service. You can't get rid of that, but now you can identify that is the piece that is taking up the most latency in your overall, architecture. And at least you can start making decisions based off of that information, right? So it's not always just I'm going to figure this out and then make changes off of it. It can also just be, I just, want to be able to describe to my stakeholders that I'm building this for what's happening, right? Why are we experiencing these pieces of latency? Or is this something that we can actually address?
Yeah, I completely agree.
Cool.
And
all right, so
I think
go on.
I think just to wrap it up, few best practices for traces, even if you're doing it by yourself, few things that would make your tracing experience much better. Tags. It's all about the tags in traces. If you're creating a span and it has nothing, it's just not meaningful. You can add tags that would be identifiers, for example, the user ID or the username or any kind of identifiers that would be meaningful for you to search or aggregate, like a customer ID, device ID, user ID. These are really the identifiers for yourself to be able to search Once a customer tells you, hey, I had a bad experience in the website, you just search for customer ID equals test, and you know exactly what's the journey that this customer had in your application. Second is about flow control. Telling your code, here I'm handling this kind of logic, here I'm handling this kind of event type. This would really help you when you're doing aggregations to understand how much time you're spending on this kind of event type or the other one, how many times does this business logic is running, and so on. This really helps understanding your application and gaining observability to it. And last one is business metrics. We spoke about it in the monitoring section, but I think for tracing, it really goes hand in hand. Items in a cart, minutes watched. Think of it like, for example, if I would jump to this call and it would tell me, okay, in this checkout, we had, 5 items in the cart. Now, I would be able to see how many items this user had in the cart over a period of time or as an average or anything, anything that might be meaningful for my business application to watch out. So these are the tagging traces. Secondly is tracing with a payload. Why not go all in with putting everything in my trace, not only text, but payloads. For example, the headers or the body of the HTTP. From there, I already got the IDs because it's probably part of some ID or body or element. What about the key or the query of my SQL or NoSQL database? If I'm calling my Postgres RDS database, I want to see the query. Why should I see just the time it took? And also, for example, what's the payload from an HTTP call? I'm calling Stripe to charge a user. I'm super interested to see what was the response, like not just the response code, the actual response from Stripe, because that would help me troubleshoot if something bad or something goes wrong. So putting the whole payload really, it's a lot to figure about skill, but if you're doing it, that's super easy. And that's exactly what part of what Epsagon is doing. And ultimately, tracing can act as a glue. As we understand that tracing is not alone. You got logging, you got monitoring, you got your environment. Traces can link you to the logs because it will tell, hey, you got this function running, for example, the logs are over there. If you want to see your logs, tracing doesn't say don't do logs. It just say treat logs differently, like search using traces and then see the logs that you've printed out that you already got there. Secondly, you want to be able to jump between trace and the environment. This trace is running on a Flask application. If it's running on ECS or if it's running on a Kubernetes cluster, I'm interested to know exactly where it was running, what pod, what container, what task, to be able to go to that environment and see the metrics of it, or vice versa. If I'm having some bad task on my ECS cluster, I'm interested to see exactly what traces are being impacted. So tracing can really act as a glue between all of the pillars of observability. I think that really leads me to, what's the best practices for observability. And, this is really boils down to the previous question about what would be the best KPIs to monitor when you're doing tracing or in general observability for your modern applications. So first thing is to have everything as much automated as possible, no setup, zero maintenance. You want to get started in a few minutes and not several days. And this is very crucial. The second one is to support your environment. Environments are complex today. You're having some functions, you're having some Kubernetes clusters, some of it running on cloud and some of it running on-prem. It can be any kind of environment and you want it to support your use case. Also, it should connect any kind of request. If your request is propagating through HTTP calls, through message queues like Kafka, through specific AWS integrations, for example, I'm putting an S3 file and it triggers a Lambda function, all should be connected. And I want to be able to search, analyze, and aggregate all of the data that I'm collecting and have the data, all of the payload and the tags get in. And it should help me solve problems quickly, or pinpoint them quickly. This is another KPI to measure, like how fast are you troubleshooting now using a good observability tool. And I know we had some questions, so Am, if you can let me know what's been there.
DJK, to shorten the name a bit, was asking around what technology pieces in the actual visualization of the the architecture graph in Epsagon. What were you using there? And I think you'll probably get into that maybe a little bit more, but some of that is probably proprietary secret magic that Epsagon has woven into its product.
Yeah, so we're using two things. We're using two libraries. I'm going to refer to the second one a bit afterwards. This one that you're seeing here is based on Cytoscape. You can probably write it down. I'm going to write it on top of here. You can probably take it to there. So it's Cytoscape Js. This is the library that we're using for the front end. Obviously, we built a lot of customizations on top of it. It doesn't look that way out of the box. But just for getting started with visualizing nodes and edges, Cytoscape.js would be the one. We're using another one for more complex scenarios, and I'm going to refer to it in a moment.
And DKG Skate Life, as Taz has informed me, is that he asks also, or this person asks, he or she asks, what about the backend?
Yeah, so the backend for Epsagon is completely proprietary. This is the main thing that we're building. We're building the observability tool that will take care to generate your traces and get them and analyze them and parse them. I can just say that it's super complex. It's composed with, I think, already 60 services in production, a lot of serverless, like thousands of functions in production, tons of NoSQL databases, DynamoDBs, Elastic Search, Athena's, S3, SNS, SQS, Kinesis, all of the services out there. It's super complex to build. I wouldn't recommend anyone to go and doing it by himself, because that would take months. But I can refer more to the technologically side if DGK Skate Life is interested more.
It sounds like if you really want to know the full back end of Epsagon, you have to go work for Epsagon, maybe. What do you think? Yeah,
that's true.
Are you hiring, Ron?
Not at the moment, and by the way, it's not related to any kind of the scenario that's going on. We raised our second funding round. We're based in San Francisco, New York, and Tel Aviv, but we're really in a good pace right now. If that's relevant, if somebody is indeed looking, you can get into the site, and there is like a careers page if you're interested to, when something becomes available to speak with us, but not at the moment.
Cool. I figured I'd give you a shout out just to get you some of that engineering talent that's currently on chat with us.
Awesome. So now I'm jumping to the demo environment of Epsagon. And by the way, this is on demo.epsagon.com. So anyone can reach it. You don't need to leave any emails or anything out there. Just go ahead and try that out. I'm going to review some of the things that happens in Epsagon that, some people call it magic. I'm calling it a lot of hard work that needs to be put down. Starting with understanding the environment, understanding what composes your environment. And as we mentioned, this can be serverless functions like Lambda functions. This can be ECS or Fargate clusters, Kubernetes clusters, AppSync APIs. Getting integrated to your account should be super simple. If you need to install agents, set up anything or do anything, that's too much work to be placed. And Epsagon doing it just by leveraging the built-in integration that AWS accounts can have, and starting with understanding our ECS clusters, services, understanding. Oh, sorry, I didn't mean to click it over here. Just to understand my service memory usage, understand what's going on, understand what's my configuration. What's the deployment configuration, what load balancer is running, understanding exactly what's going on in each and every service, or even drilling into the specific tasks. For example, all of the tasks that my order service is having and seeing the logs for understanding exactly what happened. This is, this makes your life much easier when you're troubleshooting or monitoring your environment. Now, I want to take you through a scenario of, something more serverless related. If there will be some enthusiasm from the cloud to do something like Kubernetes or ECS kind of style, let me know. But I'm going to do it serverless because I'm a big fan of serverless. I'm an AWS serverless hero, so I need to say serverless at least every couple sentences.
Yeah.
We're going to review, this is all the functions that we got in our account. Watching all of the functions can be hard work because they're placed on different AWS accounts, different regions, different stages, runtimes, getting observation to what's, happening inside the invocations, errors, timeouts, out of memories, cost, and so on. This is super important when you're getting when you're having an observability solution. And again, everything should come out of the box. You don't need to build this kind of dashboards for yourself. Now, I'm going to take you through a scenario of troubleshooting, and I'm sorting by the errors, and I've got pretty ton amount of errors, like 9K errors in the past period for my post-analysis function. This function is part of a bigger story, bigger blog site applications that we're having. And, part of seeing, just the general metrics of my service, I'm interested more in troubleshooting it. So being able to look at a function or a service, this function could easily be a service running somewhere else. And being able to see every call, every request, filter it down to only the things that matters for us. Looking only at calls that took more than a certain threshold, or even a specific call that I'm interested in. And, once we're having this kind of problem over and over again, I guess that you can see the red marks over and over again with zero division error. That's the part that I'm interested in logs. And, I could walk to my different solution that is doing logs, but how convenient would it be if I just click on CloudWatch logs and I'm having the logs all the way to me? Because logs are already there. Why should I stream them to some different third-party API solution and try to do something else if I'm already got them and they're over here? So this is the logs, but as we already know, observability is not about just logs or just metrics. It's about also tracing and all of them together. And since this problem is happening over and over again, I'm really looking forward to something that will tell me the bigger story, because this log doesn't help me in this case. It's more complex. So I'm going to click on this request to go to the storytelling part. You remember distributed trace storytelling part? I guess that even if you're not familiar with the icons, you know exactly what's going on here. There is an /new post endpoint that is being called from some user that triggers another function that apparently named request processor. Then it hits my auth0 for authentication and then publishes a message to SNS, which results in the second function, the post analysis, being failed. Now it's being failed, and this is the traceback. This is the actual exception. Again, I don't need to go to another logging solution. I don't need to, correlate anything out there. And now I'm interested to troubleshoot it. So let's see what triggered my Lambda function. In this example, it's an SNS. And by the way, it triggered it 3 times because there's a built-in retrain mechanism that Epsagon aggregates all the way for you. But now I'm interested in actually seeing the SNS message. So let's see what exact message, and this is going to the payload. I'm having the payload as part of my trace.
I see an auth0 logo there, Ron. I just have to call that out. I see an auth0 logo over there, and spoilers, or maybe this is like an insider info thing for everyone watching on stream. auth0 will also be appearing later, in a few weeks on Howdy Partner. So just
That's
saying.
great to hear.
We're in good company.
I love auth0.
Yeah,
I love auth0. We're using auth0 as part of Epsagon.
Oh, cool. Very cool. They'll be psyched to hear that, I'm sure.
Yeah. So even my call to auth0, I'm interested, I got a 401 error, and I know that everybody on the crowd knows that 401 is unauthorized exception in HTTP, which, makes sense. I'm calling to authenticate some user, I'm getting 401. But what if I would tell you that, hey, the body is already recorded? Like, let's see on the response body, why am I getting 401? And, this wouldn't have been in place if I wouldn't do manual logging or everything in place. Now, you can easily see that, plain text that our token was expired, so we need to recreate some token or do something. And, I'm troubleshooting with you some problem on some random application that we just met, but we all understand exactly what happened. I don't need to be the master of logs or to do any manual work or any manual understanding to actually understand what's going on from end to end over here. And same applies for every resource. Like, I want to understand what kind of operation was to that API gateway, or what was the stage of this API gateway, what returned to the user, what was in the headers. Everything is visible for us to explore. If there's any question, again, I'm not looking at the chat because it's hard for me to split my attention. Just let me know.
Yeah, of course. No, nothing's come up so far.
Great. And remember that I've talked about tagging traces with identifiers. Now, Mo, apparently one of my users in the website that apparently is user ID 123. Mo, your user ID 123. From now on, I'm going to call you 123 Mo. Is having some problems with my website. It can't log in or can't do something with the website. And think yourself, what would be a nightmare to look for all the events that Mo's appears in them, and I need to manage them. But look, I'm doing this kind of filter that is super simple. User ID equals 123, which is Mo. Status equal errors. In the last day, I'm going to hit the search button to see all of the matched events. And now I can easily see, first of all, how many errors am I having? This is the aggregation of my tag or my label. I can also see what's the average duration for most transactions to fail, which is, it doesn't good because it fails, but also it seems to be very slow, like 300 milliseconds or more. Now, I can actually drill down to see the exact problem. I found an event that user ID 123. I'm going to click on it, and I'll be able to see actually what happened over here. I can see the traceback, the actual traceback that led me to this problem. Now I can look at it over here so it will be more comfortable. I can look at the CloudWatch logs that led me to this problem. Like, this is the old CloudWatch log that was printed for that specific invocation. Again, everything is visible for me. I don't need to do anything to go between tools or manually print out information or tag events. Everything just comes out of the box. That's super easy. That's the way observability should be handled.
So,
you know, yep.
Oh, go ahead, Mo.
I was going to say that's pretty cool. And I was going to ask if there was a way that maybe we can shuttle these events into AWS to do anything else.
Leading the witness.
Can you repeat that? Sorry.
He's leading the witness.
I see a tab for Amazon Eventbridge, and I just want to know if there's a way that maybe we can take these events, and then maybe I can do something cool in my AWS account with that event.
Before we do that, though, I do want to surface one thing that came up in chat. So someone said, that this seems a little too complex for just some error logging, which I think that's kind of the point, right? Is that this is complex, right? Running microservices in a distributed architecture and getting this information from all of these disparate services into one place and figuring out what's taking up all your bandwidth, what is erroring out, what's giving you that 401 across a wide set of services, that most businesses are running at this point is incredibly difficult, right? Do you want to talk to that a little bit, Ron? And why it seems like it's a little complex, right?
Yeah. I just want to put my personal perspective on the complex. I know that people might be used to logs, but the other way around to seeing, this, for example, simple approach, or what we've shown before, the other alternative is to read tons of logs. And this one even might be, easy to read, but most of the logs are not easy to read, not easy to filter, and not easy to aggregate. And, this is just as an example of Elastic. It can be any kind of logging solution. This is much more complex. And think of it, it wouldn't be just a single service putting information over here. It would be hundreds of services at a scale of 1 billion events per month, putting tons of logs. And you're the one that need to figure out the logs, the correlation between one another, the full story, the exception message, so much information to read from logs. I think that, that people, like someone said, that a picture worth 1,000 words. So I think that, a trace worth 1,000 logs or something similar.
Let's see.
So this is really, the main difference between having logs that are complex to having something more easily, like visually easy to grasp. And, it can get complex, that's okay. Developing software, working on complex systems, it's not easy, but you should make your troubleshooting as easy as possible.
Yeah, and you may not, this is not maybe necessarily what you go to, as an individual developer in a service, right? This is a dashboard that you would set up for, a long-term service deployment team, but also you can utilize Epsagon as a singular developer, as I have many times, to help with debugging. It's difficult to sometimes trace, especially when you're doing complex things like, utilizing step functions, or, let's say you've got an SNS topic that fans out to, multiple different Lambda functions, and tracking how all these things go through there and other services that they touch, and then trying to figure out which one is throwing the error is not as easy as it sounds, right? And it doesn't even sound easy. So. But yeah, let's talk through what Mo brought up. Mo, set the stage for us again. You did such a good job leading Ron, right? Where you wanted. Yeah, but let's pretend that didn't happen.
I saw all these cool events, and I sometimes we see these events in Epsagon, but what if I wanted to do something with that event in my AWS account? What if I wanted to kick off another Lambda function, or send that event to an SNS topic, or whatever it might be? How would I do that?
That's a great question. Yeah. So we got an Epsagon that analyzes your traces, metrics, all of your information, and you want to customly handle this kind of data. So at Epsagon, for example, we got something called insights. Insights are things that Epsagon predicts to be a problem. For example, if your Lambda function is running slower and slower, you might hit a timeout limit. And if we already know about it, we should tell you, hey, Mo, function X is about to time out. Please take care for it before something, explodes. So using Eventbridge, we push that message to you, which then you can trigger a Lambda function, which will set adjust the memory or the duration of the Lambda function that is about to run out of time or run out of memory. And let me show you exactly how it looks.
A step back real quick. And I know this is actually Mo's one of Mo's strengths. One of many. Mo has lots of strengths. I just want to brag for it. But Mo, can you explain to us what is Eventbridge? What is this thing?
Yeah. Eventbridge is it's a serverless event bus. So it's a place where events can come in, and then we have a few different constructs, but mainly once it hits an event bus, you can associate a rule with that event bus. You can see those in the sidebar that Ron has up there. And these rules will do some filtering on the events that come in, and they'll pass them to a target if they fulfill that rule. And then that target will take that event and do whatever sorts of processing needs to be done to make you happy, since you wrote that rule.
Yeah, I mean, just to add on to that, this is an area that has long been handled by something called webhooks, right? So
and polls and polling
too,
right.
Totally.
So before Eventbridge, what would usually happen is maybe you'd have a Lambda function that was polling on a cron job, and sometimes a transaction would finish before or right after a poller polled. Let's say it's polling every minute, and the transaction polled, and the transaction wasn't done, but then the transaction completed. You would have to wait that whole minute before you got that updated status for this transaction, which just doesn't work. And then webhooks, there's obviously a lot better latency, a lot more data freshness, if that makes sense. But there's still a whole lot of infrastructure you have to manage, endpoints that you have to keep up. Network, like if I want to have a webhook API, how do my folks reach it? Lots of things to take care of. So Ron has worked with myself and some other folks to set up this Eventbridge integration, and I want to see how maybe I can pass these events into this AWS account.
Yeah, that's the big thing, right? Is all these pollers and polling and webhooks and everything. It's really just to take one event from one system that you don't control, like Epsagon, and put it into a system you do control, like AWS, right? And so then with that event information, you could trigger off all kinds of different things with it, right? So you could trigger off a Lambda function, or just pass it into CloudWatch, whatever you need to do, right? When you say polls, Mo, I just want to make sure you're talking about my people, right? The Polish. We've long been, event sourcers, right? We grab the events and we move them over as the polls. Oh, okay, sorry. I got excited. Thought you meant the Polish. Just was really excited for my people, but it's fine.
I'll give the Poles a shout out at some point.
Okay, cool.
Awesome.
Okay, cool. Sorry, take it away, Ron.
Yeah. So to demonstrate the Eventbridge integration, first thing that we're doing through the settings page, I don't want to bore you, we're creating a partner event source, which will create something like it over here. Just one moment. Let's refresh the page. So it will create some partner event source with the name. In our case, it's epsagon.com. We're going to activate it. So it's already activated, but we will need to activate it. And then, as Mo mentioned, we need to create a rule that will tell every time that we're getting this kind of event from the event bus into the event bus, I want to do something with it. In this example, it should be over here. Just one moment. So we're not looking at the default event bus. We're looking at the partner event bus of Epsagon that we created. And test event bridge is the one that I used to create. It basically says, take everything that comes in and trigger a Lambda function. This Lambda function is going to be named test event bridge. Oh, reload. Let's reload. I hope that it wouldn't require me to resign. Yay. So that's going to go to my test event bridge. And as you can see, the test event bridge got a trigger of Epsagon. I mean, that every time that Epsagon will publish a new event, a new alert, this function is going to trigger up. It's not going to do at the moment something very meaningful except for printing the event. But at this point, we can really customize our handling. And just to wrap it up, I told Epsagon, hey guys, every timeout, every out of memory, every insight that happens on any entity, just ship it to my event bus, my partner event bus. And now actually to see what's coming into my function, let's go back to the function screen. Now I'm going to look for a function named event. So let's type in event. We can see that we got the test bridge event function. I'm going to get to it, and we'll be able to see all of the calls that this function got. So we're seeing that 2 minutes ago, this function got triggered, and I'm interested to see exactly what was in the payload. So I'm going to click on CloudWatch logs, and I'm going to expand my print so I can see exactly what details got through the event bus. So there are some built-in information that comes with the event bus, and some more detailed about what Epsagon puts in. So for example, it tells me that this function had some error. The function name is random function. This how many times it happens, and this is the URL if I'm interested to dig to some more information. But that's, I just troubleshooted my function using Epsagon to understand exactly what's coming in. Last thing that I would like to finish with is the service overview. And this is, again, going back to the question of why it's so complex. So it's not that complex. I mean, let's look at our blog site that we just had. Imagine yourself that somebody would constantly watch and monitor your application in production and will visualize for you every new day or every new minute what's actually going in production. How many calls does your Stripe get, and what's the average, Auth0 gets, and what's the average latency? Or this DynamoDB, for example, which Lambda functions are communicating with this Lambda function? Or let's say I'm interested to know what's the breakdown in my service, like what takes the most for this Lambda function. So first of all, I'll load some information on the right-hand side, but I'm also interested to get into my Zen mode. So I'll reopen it to my Zen mode to understand exactly what calls this Lambda function and what calls are being made within this service, calling to SNS, S3, DynamoDB, and to understand the breakdown, like what takes most of the time. So I think that the get operation to Auth0 takes most of my time over here. So that would be the thing that I would need to optimize, or if I was looking for performance improvements, that would be my next go-to. And again, it might seem complex for some people, but honestly, the fact that everybody understands exactly what's going on over here and know how to optimize their software, knows what's actually going on inside their software, this is, you can't take it as an obvious. It's something that, using logs or using different metrics tools would be just more harder to obtain. With that, I would love to really, summarize what we had over here. So, we understand that modern applications is not only, charts and errors. It's more than that. It's more than monitoring. It's more than logging, and we need to know what's our observability strategy. And we understand that distributed tracing becomes more and more crucial, especially in complex applications. It's even if you're doing the best monitoring and the best logging, it just wouldn't fit distributed applications. And I think as a quick tip, try to not implement your own solutions. Try not to set up your own Elastic search cluster, because it would require much more efforts than you're planning to have to generate the traces, to handle the load and the scale, to set up everything, to develop everything. It would definitely put you out of focus from what you need to do in order to implement your own solution.
We had a question a bit ago too, Ron. It's pretty straightforward question. Dragon CDs asks, what about the retention time of logs on Epsagon? What kind of retention time do you all have for your logs?
So for the traces, it varies between 7 days and 30 days. For the that's for the tracing. For the logs themselves, you can look at the logs from CloudWatch logs. So what retention you would set on the CloudWatch logs would apply the same in Epsagon.
Cool. So, is it fair to say then too, it sounds to me, in the way that I kind of understand tracing or try to, is that tracing is really a great way as kind of a gateway into your architecture. And then to start diving deeper into what's going on, that's when you start referencing logs, right? You start with traces so that you could identify the problem areas. And then when you need more detailed information, that's when you actually start going into the logs. Is that fair?
Exactly. Yeah, you put it the right way.
We've got a question again from chat. Any plans to add support for GCP and Azure? It's okay, Ron. I'll cover my ears. You can talk about them.
So most of our infrastructure, most of our capabilities are agnostic to the cloud vendors. I mean, we just saw how am I tracing a Flask application that runs on no vendor. So obviously that can support, if you're running Kubernetes on Google or ACS on Azure or any other service out there. So most of the capabilities would be agnostic to the cloud vendor. We do have some, and that's currently only with AWS, tailored integrations, tailored integrations to ECS, to Lambda, to AppSync. For Kubernetes, we support any kind of environment. It means that if you're running, and now I hope that I won't forget the code words, EKS, AKS, or GKE, all will be supported. And we do plan, obviously, in the future to add support for more cloud environments in a native kind of integration. But at the moment, it's for AWS, the special kind of integration.
Cool. Sorry, I got right in the middle of your summary.
Yeah. So just something nice to get. Epsagon provides free monitoring. It means that monitoring for your Kubernetes cluster, Lambda functions, ECS, Fargate, and so on comes for free with Epsagon, completely free at any scale for as many AWS accounts that you want. And some extra benefits for people that will sign up with the following reference. So the link is pretty straightforward, dashboard.epsagon.com/sign-up with Howdy. Some extra benefits for the people that will sign up. And another cool thing, as you're seeing or not seeing, I'm wearing a new Epsagon t-shirt. And well, obviously you don't know that it's new, but that's relatively new shirt, super cool, super, popping out. If you're interested in, having this kind of shirt for you as well, epsagon.com/Twitch, you would get this shirt, I promise, crossing fingers. That's it. Thank you, guys.
Wow, you gave away swag, Ron. That's crazy. People are going to really have to step up their game on this show. You really set the bar very high for a first episode, giving away shirts. That's pretty crazy.
Thanks. That's my pleasure. That's as I told you, live sessions. That's me doing code that fails on live. That's what I like.
You didn't have any failures.
Maybe you don't know. Maybe I just covered them up.
That's perfect, man. That's amazing.
Maybe everything that you're seeing over here is a recorded video. Who knows?
That's true too. You know what? That happens to me on stream a lot. Is that people don't believe that we're actually live, and then they make, like when I used to do these shows with Nikki, which shout out, probably AM and Nikki season 4 coming at some point in the future. But people would make her put her shoe on top of her head to prove that we were live. I don't know why. It was like a thing that they did. Yeah. So Mo, I'm
having this one, a sandal, and it's going to be on top of my head. That's what the challenge is.
Yeah. Glass. Boom.
Boom. Live proven. Drop the mic. Everyone buy.
Well, how was your first stream?
I think it was pretty chill, no?
Yeah. Did you enjoy it? Did you like?
I think I enjoyed it. Some folks are still asking if the chat is pre-recorded.
Ooh.
I can't put my shoe on top of the chat.
We hired a lot of paid actors to watch.
We're deep fakes, right? Like that's all that we are, deep fakes. Yeah, cool. Ron, I can't say thank you enough. This was incredible. I really don't think it's going to be tough for everybody else who has to follow you. I just have to say that, But thank you for kicking off Howdy Partner.
Episode 1 in the book.
Yeah, I hope you will come back. And for everybody still on, we are going to be doing Howdy Partner every Monday and Wednesday starting next Monday. So there's no show on Wednesday of this week, but starting on April 27th, is that right? Am I doing time? Am I doing the time?
You are.
Yeah.
I did the time. 27th at 2 to 4 p.m. Pacific, just like today. And then every Wednesday at 2 to 4 p.m. Pacific, there will be a new partner on. Mo, do you want to announce who's going to be joining us next week?
Next week. I'm not sure who's joining us next week.
Okay.
We can check.
I'll tell you. I'll give you some hints. Maybe you can guess.
Okay.
So they do something with Elasticsearch.
Oh.
And S3.
Are they based in Boston?
They're based in Boston. For those of you asking for the shirt, it's up on the screen now too.
I'm intimately familiar with Boston-based tech companies. It has to be Chaos Search.
It's Chaos Search. Chaos Search will be joining us next Monday, so a week from today. But we have been just dazzled and entertained by Ron from Epsagon today. Be sure to go sign up. We dropped a sign up link in that chat, and we'll be back for more Howdy Partner. We're so happy to have You joined us today, Ron. Thank you again.
Sure, that's my pleasure.
Any parting words?
I hate to say goodbye. I wish this live could last forever.
You can say yeehaw, giddy up,